We're going to talk today more about evaluating functions. So let's refresh a little bit. Remember that inputs are our x's, and we can also call them our domains. They're the domain value. They're the first value in a coordinate pair. So if I have a coordinate pair of, say, 3 and 2, our 3 is our x value, which can also be called our input, and it also can be called our domain. It's also an independent variable. So if I was thinking about a graph and I wanted to graph these points on a coordinate plane, and let's say I had 1, 2, 3, 3, 2, 3 is independent. Your x variables, your x-axis is always the independent, and your y is dependent. So remember that just like in science, something controls something else. The independent controls what the dependent is going to be. And it makes sense because if we input something, depending on what we input, is going to control what the output will be. Now the y value, or the second value in our coordinate pair, is called the range or output, and it's a dependent variable. Now remember we talked a little bit about function notation yesterday. So function notation is a way for them to tell you that there's a rule that's happening. And this would be f of x, that's the way we say it, f of x or g of x. F of x is the most common one used, but they can use any letter and any variables. So this takes place of the y. So if I had an equation like y equals 3x plus 2, all I'm doing when I'm saying f of something is I'm writing a rule of like future predictors. So I'm saying anytime I use this rule, whatever I put input, it's going to tell me my output if I put that amount in where my x is, or whatever variable is written here. So if this was a here, there would have to be a over here beside the 3 to know where to put it. Okay, so remember input just like a function little machine. Whatever I input then gets manipulated by the machine, whatever the rule is, and boop, 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 and out pops the output. And it's got to follow that rule. So remember, to know if something's a function, we don't want the x repeating. So if I have a list of x and y's, say in a table, and I have 2, 3, 4, I can have the y's repeating. I can have a 5 and a 5 and a 5. That's fine. Every time I put 2 in, I'll get out of 5. Great. I put 3 in, I'll get out of 5. 4 in, I'll get out of 5. But if all of a sudden I have a 2 and I get out a 2, this x is repeating, and that's giving me a different output. That would not be a function. Now, let's look at this rule. We have f of x equals x plus 4. So it'll ask you to find what's f of 0, or f of 1, or f of 2. And I did a little table. So remember f ofs, whatever's here is your input. So 0, 1, and 2. My f of x stands for my y. That's why it's over here on this side. And I'm going to use that rule, x plus 4. So this is my rule I'm using. So if I put in 0 for my x here, 0 plus 4, so 0 plus 4, I get out of 4. If I put a 1 in for my rule, it's 1 plus 4, and I get out 5. If I put a 2 in, it's 2 plus 4, and I get out 6. So for this rule, if I input f of 0, my output is 4, f of 1, output is 5, and f of 2, my output is 6. So these are just coordinate pairs, 0, 4, 1, 5, and 2, 6. Okay, so we're just evaluating. Now, we can do the same thing when we have something squared. So we talked briefly about what squared means. So remember, squared doesn't mean if I have a number like 2 squared, that's an exponent. It's not saying 2 times 2. It's saying 2, whatever the base is, times itself that many times. Now, this one happens to be 4. And we think, well, wait a minute, how'd that work? But let's think about it if I did 3. So let's erase here, and we'll do 3 squared. So if I do 3 squared, that's the same thing as saying 3 times 3. The base number times itself that many times. Well, 3 times 3 is 9. It is not 3 times 2 and get 6. So understand what you're doing. So here I have a rule, my x squared plus 3. So when I put in that rule, what am I going to get each time I put in these inputs? So I'm going to go ahead and take my inputs from my find side into my table. So -2, -1, 0, 1, and 2. And now I'm going to find my rule. So I'm going to plug in my -2 where my x is. So this is how it would look. -2, I'm using parentheses because that negative being squared, the whole negative is being squared. Square plus 3. That's the same thing as saying -2 times -2 plus 3. Well, -2 times -2 is 4. 4 plus 3 is 7. So this whole amount here is actually equal to 7. Do the same thing with my -1. -1 squared plus 3. That's the same thing as saying -1 times -1 plus 3. Well, negative times a negative is a positive. 1 times 1 is 1, plus 3 gives me 4. So my input, when it's -1 into this rule, gives me an output of 4. 0. 0 squared plus 3. Well, 0 times 0 is still 0. Plus 3 gives me 3. 1 squared plus 3. 1 times 1, because it's squared, is 1, plus 3 gives me 4. And then when I have 2, it's 2 squared plus 3. 2 times 2 is 4, plus 3 gives me 7. So notice how 7 repeats, but that's an output. That's okay. It can repeat, but my inputs did not repeat and give me something different. Now here's how you may see this in a word problem. So this is about function and formula. So David wants to fill up a spherical water balloon. So think about a circle, like something a 3D shape, a circle, a spherical when we blow up a balloon. So that's important to know. We'll talk about learning this formula later. And he wants to fill it with as much water as possible. The balloons that he bought can stretch to a radius. So let's remember what a radius is. If we're talking about a circle, we're talking about from the center point to any spot on the circle. So any spot. So from here to here is a radius. Remember, going from one side to the other all the way across, that's diameter. So we know it can do a radius of 3 inches. If the volume of the sphere is the function of V of R, it's 4/3 pi r cubed, what volume of water in cubic inches can David put in the balloon? So it seems very complex, but really all we're doing is we're using our function rule with the formula given, and it's telling us that our radius is 3 in the problem. So everywhere we see R, we're going to plug in 3. So V of 3 is a function of, and we're going to use our formula, and now we're going to put our 3 where the R is. Now, we're going to go ahead, and you can use your calculator or Desmos calculator, but 3 cubed is the same thing as saying 3 times 3 times 3. Well, 3 times 3 is 9, and 9 times 3 is 27. So this becomes 27, and these are all being multiplied because they're right next to each other. Well, I'm going to leave it in terms of pi. Pi is normally worth 3.14, but I'm going to leave it in terms of pi. So we'll just leave pi alone, but we need to simplify 4/3 times 27. Remember, you can make anything look like a fraction by putting it over a 1, and let's cross reduce. Well, 3 can go into 3 one time, and it can go into 27. 27, 3 times what is 27? Well, I know that is 9. So then I just multiply straight across. 9 times 4 is 36. So my answer would be 36 pi cubic, because cubic is 3D, inches. So that's the amount of water he could fill in that balloon, because volume is how much water can be held inside of something. All right, another example of what you might be asked to find is using the data table they gave you to answer a question. So this data table talks about people's age and their shoe size. So it says, is a person's shoe size? So they're asking, is the shoe size a function of their age? That means, does their age determine their shoe size? Well, let's look. If we see any x's repeating, or inputs, so we got a 5 and a 5, they repeat, but one 5 gives us a 2 shoe size and one gives us a 3. So the shoe size is not a function of their age. That means the age of a person does not determine their shoe size, which makes logical sense because even your friends have different shoe sizes than you, and most of you are close to the same age. So this is no, because We have a 5-year-old that has a size 2 shoe and a 5-year-old that has a size 3 shoe. So this is not a function. All right, then you're going to be asked to find some outputs or a function on a graph. So here's a picture, and I just took from Khan. So it says the function f of x is graph. So all this blue is the graph of the function. Well, we can look at our vertical line test, and if we took and did straight lines across, we can see this is a function because no two spots hit at the same time. So we know it's a function, and they're telling us a function. It's not trying to determine that. But it wants to know what is the output when our input is f of 1. Remember, inputs are our x's. So if we're looking at -1 is right here. We want to know what would the output be? Where's it going to hit our graph when we put in -1? Well, it hits at 6. So f of -1 for this function is 6. Well, let's say I wanted to know another one with this graph. Let's say I want to know f of, let's see, 7. So I go and find my input of 7, and then I continue myself up, and where it hits the graph, I'm going to look, that is 5. Maybe I want to know the input of 0. What's the input of 0? What is the output when the input's 0? Well, here's 0. Go all the way up, it hits 8. So I can read a graph as well.